Okay, why don't we go ahead and get started here? I want to welcome everybody to the third session of the AIA Oregon 2025 Fire Resilience Series. My name is Kurt Wilson, an AIA member and architect in Eugene, and one of the members of the series planning committee, along with Jay Raskin, Alan Scott, Logan Kelly, Charles Kelly. On behalf of our committee, we'd like to thank our sponsors for their generous support and to Kathy Winland of AI Oregon. As a reminder, please mute your devices and when you're not speaking, and we encourage you to put your questions in the chat. We'll have time at the end of the session to have a conversation with Cameron about his presentation. So the AI Oregon Fire Resiliency Series is a 5-session series scheduled at this time on Fridays and concluding with a panel discussion on October 24th. Go to the AI Oregon website for more information and to register. Our first session was led by Nate Vidasek and included an in-depth information hardening strategies based on fire behavior. Our second session was led by Evan Schluter and was an analysis of the LA County and Lahaina fires and provided a unique account of the relationship between wind, fire, and fuel. If you didn't get a chance to see those presentations, go to the AI Oregon YouTube channel to find the recordings. And this is on the screen is the continuing education information and for the session, and for AI members, you're eligible for 1 credit for today. So more about today's session. So while the first 2 sessions focus on fire behavior, and mitigation strategies, today's session, which will be led by Cameron Beeks, will focus on the impacts of smoke and discuss building and mechanical system design and operational strategies to protect indoor air quality during hazard events, and will introduce new standards and publicly available information to guide these solutions. Cameron is GLUMAC's Director of Market Sectors, an executive team member, a vice president of the firm, and a mechanical engineer by trade. Cameron has designed a wide range of projects from lab facilities, higher ed, K-12, and performing arts centers, to name a few. He is also an adjunct faculty at the New School of Architecture for the Sustainable Design and Technology track, and he has guest lectured with engineering and architectural programs nationally on sustainable design solutions and environmental quality. He's contributed to EPA's efforts to enhance school facilities during heat waves and wildfire events. Very excited to have Cameron join us. Cameron, welcome to the AI Oregon Fire Resilience Series.
Thank you so much for having me. Really excited to be with everybody. Really excited to be back in the Northwest. Not today necessarily. I'm actually traveling for celebrating a wedding within my family. So I'm out in Arkansas today, but I moved back to Oregon about 3 years ago now, and it's good to be home. Grew up in Oregon and spent about a decade in LA while I was away. And so watching Evan's presentation, and I've actually worked with Nate quite a bit on several projects down in Southern California, but watching Evan's presentation specifically on the LA wildfires really hit home. I had a handful of friends who actually lost homes in the Palisades fire. So it was very devastating. Today, I'd like to kind of orient everyone as to what this presentation is going to touch on. Let's see, I'm trying to get the slide to progress next.
We're still seeing the cover of the title slide.
Yep, I am just trying to get it to go to, there we go. It unstuck itself and then jumped way ahead. Super. Well, Kurt, thank you for the wonderful introduction. Why me? I've spent a lot of time working on resilience studies, both for the EPA and then worked very closely with our team here at GLUMAC on the resilience framework for the Cal State University system, and sit on the mechanical review board for the Cal State University system as well. I love working with architects. I active adjunct faculty at New School of Architecture and help out in a handful of studio reviews across the country for architecture programs and architectural engineering programs. I had the learning objectives up really quickly, but just to go over them again, I was kind of framing today's presentation, thinking about the holistic consultant, and I think that holistic consultants are very much what architects are. How do you run your business? What do we need to worry about as far as our occupants go? What are the systems within the building? What sorts of operational concerns do we need to have? I feel like the architect is the glue or the master juggler that pulls everything and everybody together so that the business operations or the living operations can occur for these building owners as well as the occupants. And so that's kind of the lens that we're going to look at this issue through today. So first, as a master consultant, where can I find this information relative to my site or to my project? And then looking at what are the performance metrics from a business case standpoint and also a health standpoint. How do I have this conversation around wildfire smoke with a client, and how do I raise this as a concern when appropriate? And then we'll be looking at a handful of strategies. There will be a handful of strategies, of course, that are on the architectural front, and then you'll see several that have to do with HVAC as well as operations. And it'll include a mix of both proactive and reactive strategies that are also both passive and active. Yeah, so diving into it, we'll start first with wildfire and indoor air quality. And again, we're entering the middle of a conversation here. Nate did an excellent job talking about what sorts of design features can be deployed to protect buildings from fire. Evan, of course, touched on additional fire resilient strategies. Again, really honed in on fire spread and the actual fire. But today we're really going to be focusing on wildfire smoke and indoor air quality. And so ASHRAE 44 is the new standard that came out in December of 2024, so at the end of last year. And the way that they refer to smoke in this instance is actually wildland fire smoke. And there's several health concerns that are associated with wildland fire smoke, and that has to do with the composition. The composition of wildland fire smoke is a combination of particulate matter, gaseous pollutants, ozone, volatile organic compounds, and PAHs. Each of these has an adverse effect in a variety of ways, but to go through them kind of from a biologic standpoint, I'm going to cover four major areas: the respiratory concerns, cardiovascular concerns, neuro and developmental, as well as the fact that they do present a cancer risk. So first, respiratory. This is largely the particulate matter, the PM 2.5 and the PM 10. Really, it exacerbates anybody with chronic conditions such as asthma or bronchitis, anybody with a reduced lung function. It does have a significant concern with regards to respiratory effects. And then cardiovascular, because our lungs are pushing what we're breathing, this oxygen, into our bloodstream, it has a big impact on our heart as well as our organs. So there's an increased risk of heart attacks. You actually have people doing blood work on those who are exposed to poor air quality and seeing that there is a vast difference between those who are exposed to clean air quality and those who are exposed to poor air quality. There's great research being done by environmental justice workers across the country in academia, specifically at University of Washington. There's great research going on as to what are the health effects or long-term health effects of those that are in wildfire-prone areas, and does the smoke have a long-term effect on them? And more and more, the answer has been yes. But there's also acknowledgement this is a relatively newer science, not newer in that we're suddenly becoming aware of it. It's just there's a lot more data now readily available to study the health effects at a large scale, as well as correlating that with wildfire smoke. And then neurological and development impacts. There's evidence of cognitive decline, developmental delays, and mental health stressors for those who are exposed to excessive wildfire smoke. And then, of course, cancer presents a risk. So of course, I hope that that's enough motivation for everybody. But there's a big population that also we need to pay special attention to, and that's why the EPA had me involved and the GluMac team involved in how do we create clean air zones for children, those who are most vulnerable to wildfire smoke, and so that would include the elderly, children, people with chronic conditions, as well as pregnant people. But for those of you who aren't necessarily just motivated by the health side of things, or perhaps have clients that aren't ultimately motivated by the health side of things, I wanted to include the business case as well. I'm going to start in the space of academia or education, because that's I previously looked after our education practice for the firm. And one of the things that we do is we try and understand what's the formula for funding for the various schools. And in Oregon specifically for K-12, the number one funding mechanism in the calculation is average daily attendance. There's of course other aspects, special education needs, English language learners, and poverty support. So there's a big demographics component that goes into that calculation. Test scores in Oregon are not a factor, but they can be associated with grant funding. But the biggest factor, again, is average daily attendance. And when you look at a lot of the publications that are out there, the one that I lean into because it's just so well written is the Harvard Healthy Buildings for Schools and Student Success, and air quality is the leading cause of absenteeism. So again, if I'm designing a building and I have the business case front and center, I'm looking at what is my leading cause of absenteeism and correlating that to the dollars potentially gained or lost with that formula for funding for schools. In a more general sense, the Building Performance Institute of Europe has put out publications recently that air quality can see an uptick in performance by 3 to 6%. And then have also been several studies from universities across the country, but one I highlighted off to the right there is a study that was done by Dr. Cadeno Laurent, who is he's an associate professor now. He's moved on from Harvard, but in his time at Harvard, he was doing studies on acute exposure to excessive amounts of particulate matter, PM2.5, and he did see cognitive decline both in the ADD test as well as the Stroop test. So there is a business case to this, as well as just it is the right thing to do. And so there's several maps that are available through FEMA. And again, this is the part of the presentation where it's, does this impact me? Does it impact my project? How do I find this out? So I'm going to be highlighting a handful of tools here to show you that you can potentially bring up in your consulting practice. So FEMA, of course, has several maps, but the one in particular that I want to point out is actually with the U.S. Environmental Protection Agency. They have a tile plot here that's very easy to understand. It's a fantastic tool. I included a link here in the presentation, and I can work with the Oregon AIA to make sure that these slides are available, or at least the links. And they produce reports just like this. And so you can see down here at the bottom is the air quality index category, and they have them color coded where green is good, yellow moderate, orange is unhealthy for sensitive groups. So again, the sensitive groups we previously discussed. And then red and beyond into purple is unhealthy for the larger general public. And you can run these reports and get a very quick glimpse as to whether or not my particular areas of concern. Now, this particular graph is for Multnomah County. So I just simply went onto the website, I clicked on Multnomah County, I ran this from 2010 to 2025, and I can see here that generally for Multnomah County, it ranges between good and moderate. There was, of course, the big wildfires that occurred in 2020, and then there was a handful of poor weeks in 2018. But if I'm in Multnomah County, I would have a conversation around it happens once every 3 to 5 years, a bad fire event, or maybe once every 10 years. We can look at doing a proactive strategy, or we could look at a potential reactive strategy. It depends on the critical nature of the facility. So looking at this particular data set, again, for Multnomah County, it doesn't have me doing a large knee jerk as a consultant to the building owners. Again, understanding that there are or have been in the last 10 years significant wildfires, I'd look at a potential plan for addressing wildfire smoke should it occur. I have a couple others. So this is Lane County. And you can see that wildfire smoke continues to be a trend year over year in Lane County. So again, this is a county where I would look at having a conversation with the owner around a proactive system or something that's already in place or well defined that could be deployed in the event of wildfire smoke. And then again in Deschutes County, so out towards Bend, again, year over year or every other year, it's significant periods of time. You can see that these are months across the top here. So your idea of scale, this appears to be, this purple line right here appears to be about 2 to 3 weeks of really poor air quality. And that happens year over year. And then again, Jackson County down near Medford. So again, it's several weeks in a row of really poor air quality. So these last three that I shared with you, it's a little bit more prevalent wildfire smoke, and so I would recommend a little bit more intentionality around ensuring that there's appropriate systems to address the wildfire smoke, since it is a recurring trend year over year. But this does look at the entire county, and it does look at all data in that county. It's not for a particular site. So I also want to introduce to you, there's another website called airnow.gov. And the beauty of airnow.gov is you can look at these, you can look at the air quality on a map basis. And if you actually hit the drop down right here at the top left, when you open up airnow.gov, you'll see that there's an option to select monitors. You can select PM 2.5, you can select all monitors, you can look at just PM 10, and then any of these little green bubbles or yellow bubbles or red bubbles, depending on how the system or area is performing from an air quality perspective, you can click on it and you can actually get the number right there for that particular air quality station. So this is 4106-70005. And then I can go back to my multi-year tile plot that's provided by the EPA, and I can match up and choose that particular site. So I can really zone in on just that very specific location near my project site, so I can do the best type of consulting I can instead of looking at the worst case for an entire state or an entire county potentially inappropriately. Now, when I teach my students down in San Diego on how to use this, if you do start to see results where there's a lot of gray, just pick another station nearby. Not every station has all of the PM 2.5 information or PM 10 or ozone, or perhaps there could have been an issue with that particular station. And so just choose the next one nearby. All right. So that should be hopefully during your concept phase and when you're having conversations with your clients, that's hopefully a tool that you can start deploying straight away. So now I'm going to shift into, again, ASHRAE 44, the new standard that was produced in December of late last year. And then also I'm going to be highlighting some of the guidance that we've developed and with the EPA, as well as other work that the EPA has developed beyond our specific work with them. So smoke mitigation, this diagram right here is from ASHRAE standard 55, which is our air quality standard, and it highlights all the different locations where filtration could occur or potentially infiltration where air is coming through the facade. So there's an area near the zone itself for outside air to come in. You could of course have outside air come through the facade. You have your dedicated outside air systems that could be bringing air in, and then for recirculating systems that aren't dedicated, you have additional opportunities to add filtration or where additional outside air could be entrained. So looking at a much cleaner, more architect-friendly diagram, that translates to these areas here. So you have the smoke that could come in through the outside air system or an air handling unit system. It's supposed to go across filters is the idea, and it can also come in through the facade. You'll hear me talk a little bit about these portable filtration units throughout the presentation when it comes to potential strategies you could deploy, but the two largest areas where smoke can come into buildings is through the HVAC system as well as through the envelope. ASHRAE 44 talks about achieving a level that is, they call it ALRA, as low as reasonably achievable. When the air quality is really bad outside, we just need to try and do our best effort. We're not going to prevent all the smoke, or it's very unlikely we're going to prevent all the smoke, but we should try and do everything that we reasonably can to prevent the smoke from coming into the space. And the risk categories, again, this is for 1 hour of exposure for PM 2.5. I wanted to make sure that you had this metric as well. And a lot of what ASHRAE 44 talks about is mitigating PM 2.5. And again, that's particulate matter. That's 2.5 microns across. And then there's different levels of concentration here, but you can see the risk categories associated with each of these, again, with when these slides become available, or if you want to go and refer to this on the YouTube page. So what are some architecture design strategies? And again, I've kind of grouped them into two separate types of categories, one of which is really addressing the envelope, and then the second of which is looking at having fresh air zones or having a space that you can provide refuge. I'll share a couple of anecdotes on that as well. So the envelope considers all openings as well as the envelope itself that are unintentional openings. So ensuring that we have vestibules or having multiple doors to go through so we don't have a direct opening to the really poor air quality that's outside. If you can do this multi-stage door approach, especially as you're protecting more and more sensitive areas. So if you're doing hospital design, again, having to go through multiple doors to create these kind of barriers to seal the smoke from getting to your most sensitive groups is important. When you're doing your envelope design itself, ensuring that you're using appropriate gasketing, looking at each of your details around the windows, around the doors. Oftentimes what comes to mind is two glass doors that come together that don't have an appropriate gasket between as those two glass doors come side by side to one another. Looking at any sort of weathering that might occur on the envelope. Now that's more for existing buildings and the weathering that could occur on those gaskets, and then limiting direct openings, especially for places of refuge. But again, it's that idea of having those vestibules or having those kind of multiple layers for that smoke to go through so it doesn't come into your most occupied areas. Then there's this concept around fresh air zones. So these would be clean air spaces. And this is really the work that I was working on with the EPA with is, how could we have areas that we could have this clean airspace zone? And the concern was the EPA was recognizing that there wasn't as much cognitive function on poor air quality days. And so could there be an operation plan with the K-12 institution of having the students go to, maybe it's the gymnasium, maybe it's to the auditorium, and having just a lot of investment on the gymnasium or auditorium itself, instead of having to do entire school upgrades. So for the days that have really poor air quality, just having all the students spend that day in the gymnasium or in the auditorium in lieu of being in their individual classrooms. That just from an economics perspective was a lot easier for the schools to manage doing that those one or two or three potential spaces, doing upgrades for those as opposed to upgrades across the entire building. But with that, we had to look at compartmentalizing, look at circulation and traffic, and trying to limit, using these zones that were being used for fresh air so that there wasn't a bunch of traffic inside and outside, inside and outside. Each of these zones, we want to make sure that we're doing positive pressure. You'll hear me talk about that in the mechanical, the HVAC section. But making sure that we're not pulling air into the building, because whenever we're pulling air into the building from the outside, that's just going to pull air in from any nook and cranny. Again, kind of going back to the importance of the gasketing, really good envelope, so we can't pull that air through. But if the building is maintained at positive pressure, we should actually be pushing air out of the building instead of pulling smoke potentially through the gaskets or through the envelope. And then making sure that we have appropriate signage and wayfinding. So from a smoke mitigation perspective, those are some of the things we can do architecturally, and I can talk into more details on any one of these as people have questions. Then there's a handful of HVAC system design strategies that I'm going to be highlighting. Of course, filtration fans. I'm going to talk a little bit about building automation controls, positive pressure and air quality sensing. The filter and fan capabilities. Now, Oregon really celebrates decoupled ventilation systems. What that means is that I am using a separate outside air system from my in-zone cooling and heating systems. So a lot of people might see series fan power boxes, might see variable refrigerant flow, see chilled beams. Those are the types of systems that I see in Oregon because we're trying to reduce what's called reheat energy losses. It saves a lot of energy. There's one note though, is when we look at these decoupled systems, the terminal unit or the heating and cooling unit that's actually in the zone in the space, providing the heating and the cooling, like with a variable refrigerant flow system, those are often hard to get MERV 13 or better filter on them without special consideration. And then chill beams, of course, don't have filtration on them. And so those could just be simply recirculating the air. Now, I'm not saying don't use these systems because these systems are very much a good thing from an energy perspective, but just work very closely with your mechanical engineer, especially if you are in a wildfire smoke prone area. And then packaged terminal air conditioners, the ones that just simply go into the wall. The way that those work, some of the major manufacturers, the outside air actually bypasses the filter, where the filter just recirculates the air into and from the space and then pushes it back into the room. And so that outside air just bypassing the filter right there, that's just going to pull whatever smoke is outside. It's just going to pull that right into the space. So just a caution on packaged terminal air conditioning units. I know that they're a very cost-effective solution that I see used a lot, and whether it be student housing or multifamily housing, but just note that there is a concern of not being able to filter the outside air very well. Now, centralized equipment like air handling units or dedicated outside air systems, the ones that are up on the roof, those tend to have plenty of adequate pressure to handle a MERV 13 or better filter. And so what do I mean by a MERV 13 filter? MERV stands for the minimum efficiency reporting values. Effectively, it's just how much of the little particles can I get out of the air. So MERV 13 is what's been recommended from ASHRAE, or MERV 13 and better. You'll see in California, there's OSHPD standards or HCI standards that require MERV 14 or MERV 15 in some instances. But a lot of those smaller units that I was talking about, those zone level decoupled systems, they tend to see only a MERV 8 for those applications. And again, we're looking at PM 2.5, which is the center column right here. We're trying to get rid of those guys as well as the 3 to 10 micron particulates. So you can see that MERV 13 does better than 90% for those particulates. That's great. When we look at the wildland fire smoke composition, so we've talked a lot about taking care of the particulate matter. That's just one part of this, though. We also have these gaseous pollutants. We have ozone, we have VOCs and PAHs. We also have another type of filtration, activated carbon air filters that can help try and address gaseous pollutants, ozone, VOCs, and PAHs. Some notes on carbon air filters, though, for those of you who haven't worked with them. They do have a shelf life. Once you open the package, that starts the expiration process for the carbon air filters. They'll start to absorb chemicals and fumes straight away as soon as you open them up. So the other thing is that you have to make sure that they're appropriate for the type of use that you're deploying them. Not every carbon air filter is the same, and so just making sure you're working with your mechanical engineer or with your vendor for your filters to ensure you're getting the appropriate carbon air filters. And then I'll talk about it in a little bit more detail, but there is additional pressure drop associated with these filters. And so we'll have to make sure we check the fan's capabilities. One important note is that carbon air filters do not replace particulate matter filters. You need both. They need to work in tandem with each other. You cannot have just a carbon air filter without a particulate matter filter. And then positive building pressure, I talked about this very briefly, but we want to be pushing air out of the building, not pulling air into the building. So just imagine if you were to have the door cracked open a little bit and all the smoke comes rushing in. We want to be pushing the clean air out, or we want to be only pulling clean air in, which means we want to be pulling it in from our HVAC system across the filters. And so some operational considerations that you could advise to your clients would be disabling economizers. Economizers mean that when it's really nice air outside, we want to pull in more outside air just because it's going to save us energy. We want to disable those during a wildfire event. And then we want to address negative pressure systems, trickle vents, or the little openings that occur at the bottom of windows or in the window frame itself. Trickle vents are oftentimes coupled with a bathroom fan. And the bathroom fan runs all the time and it pulls air through the trickle vent. The trickle vents do not have any sort of filtration on them. And so if you see a system that, like in a multifamily housing scenario, that's the best example where I see this most often. They'll run the bathroom fan in the apartment, and then they'll try and pull air, whether it be through the trickle vent, or they'll just simply try and pull it through the facade. They'll try and justify that I have enough pressure, negative pressure, that I can pull air through the facade. In California, and I have not confirmed if this has been reflected in the Oregon code, but in California 3 years ago, the code was updated to require that if you do have a system that runs negative pressure exhaust as your means of ventilation, you have to have a switch there with a sign that says only turn off on poor air quality days, and the occupant has the ability to go in and turn that fan off, because otherwise it would just continue pulling the smoke into the building. And then air quality monitoring. So this is a combination of architecture as well as mechanical engineering, but just looking at where do we want to put these? Air quality monitors would be great at outside air intakes, of course, but again, we could also leverage the data that's available from the government, like airnow.gov. But we want to have them at building entries, high occupancy areas, or especially critical zones where there's sensitive groups of people. Having these next to return grills will also be really helpful, because it gives us an idea like what is the quality of air that we're recirculating back into the system. If you have clean air zones, it would be good to have an air quality monitoring station in one of those clean air zones just to see how you're doing. And then also mechanical rooms where you have air handling equipment. And there are several types of air quality monitoring devices. There are several of the major controls providers are offering air quality monitoring devices, but then there's also several devices that have been recommended, whether it be by the EPA or by ASHRAE. Okay. So I'm going to shift from some of the design aspects. I'm going to go into operational strategies. One of the big things that ASHRAE talks about, as well as the EPA, they talk about smoke readiness plans. And this would be working with, or having the building owners work with their teams to go over what are we going to do when we are presented with wildfire smoke. What is our communications plan going to look like? Do we have to go and replace the filters? Are we going to prepare a clean air zone? Thinking about that application of the K-12 application I was describing, where the students would go and have classes in one of the auditoriums, it takes a lot of preparation in order to get the students moved in there. It also requires communications out to the parents, to the teachers, as well as to how they might need to change their days. So one thing that ASHRAE talks about is changing the behaviors, or changing some of the activities that the school does during the day. Maybe instead of having our pacer test where we're running back and forth, maybe today is going to be a stretching and recovery day. Some other operational strategies, again, in a more proactive sense, would be commissioning and envelope commissioning, just making sure that that envelope is nice and tight. Having a smoke mode on your building automation system just ready to go. And again, that would do things like disabling the air side economizer and ensuring that there's good positive pressure in the building. Some other proactive steps, of course, would be making sure we're replacing the filters and doing routine maintenance. When we were working with the EPA, we actually worked with, I believe it ended up being 5 or 6 different counties. And a lot of the conversation at the end of the day was with the facilities teams just saying, we're so understaffed and we can't keep up with just the routine maintenance. If I were to go and put these filters in, like the fans just aren't maintained well enough to handle that static, or the fans might break, was kind of some of their concerns, which I have a couple of slides on that too. And then just making sure that everything's in stock and ready to go from a filter perspective. If you are going to deploy additional carbon filters, that was one of the things we looked at doing at, I believe it was Cal State Northridge as well as Cal State Long Beach, where we were looking at lab as well as academic spaces where we had a space for carbon filters to go into that could be installed throughout all of wildfire season. And then they could be taken out when you're not in wildfire season. And so you would make sure that you have those filters ready to go in stock and sealed in their packaging, of course, so that if you did have a fire like the LA fire that occurred in January, which is not during the typical wildfire season, those could be readily deployed. And then the PACs, the portable air cleaners, having those in stock. I was working with a private university in Southern California that I believe they bought 800 of these during COVID. And so they have a big warehouse of portable air cleaners that are ready to be deployed. And then there's strategies that you can deploy from a reactive perspective. Again, that smoke readiness plan, deploying that plan, having advisory signage, where people need to go, what people need to know, making sure that the envelope's tight. And when I say this, it's not necessarily going around and caulking all of the windows during a wildfire or preparing for a wildfire event. It's just to make sure that people aren't opening the windows on that day, or if you have turnstile doors, making sure people are using the turnstile doors instead of just using the normal doors, and creating those direct openings into the building. So just putting up the signage to encourage people to use doors or exit and entrance pathways that reduce, again, the direct pathways into the building for smoke to get in. Building automation system controls, that's very much an excellent reactive strategy. Deploying your enhanced filtration, and then deploying portable air cleaners. Again, the proactive strategy is having it all in stock. The reactive, of course, is deploying it. When you're working with your clients, just make sure you have a conversation around the facilities team's manpower or their ability to scale up and deploy all of these needs. They might be very short-handed, and so they might only be able to put up signage. Asking them to also deal with additional filters or deploying portable air cleaners, they might not have the hands or people readily available to get all those things done. So I've talked about the smoke plans a couple of different times. The EPA has a smoke ready toolbox that you can see as an example. ASHRAE has a planning framework for protecting commercial buildings. My team worked on the Cal State University Climate Resiliency Framework, which covers things that include wildfires, but go much beyond that as well. It looks at heat waves, power outages, water droughts, so on and so forth. But each of these could be leveraged for crafting your client's plan that they could deploy during a smoke event. And then a couple notes on portable air cleaners. They recirculate the air in the space. They just watch out for acoustics when you're looking at portable air cleaners. Matching a portable air cleaner with a K-12 environment can be a little bit of a trick because the acoustics are a distraction to several of the students. And then just making sure that they're being placed in an effective part of the room. This was a big emphasis during both COVID as well as during the 2020 fires of trying to locate these appropriately throughout the room so that they're ultimately effective. So just reach out to a mechanical engineer or work closely with the manufacturer on the actual placements for these. Because if it doesn't properly get the air to move and recirculate in the room, you won't be able to get certain pockets of the room and try and clean up what we would consider to be that breathing zone for the occupant. A couple special considerations: healthcare facilities, just making sure we're looking at really enhanced filtration, even HEPA filtration, just for that short term, for super critical areas. Just making sure that the redundant systems are operational is really important, and then having protocols and staff training. Schools, again, I talked about that activity modification, disabling the economizers, and having communication plans. I think I've brought that up a couple of times as well, because the parents are going to want to know what the plan is to address this wildfire smoke. And then for the multi-unit residential, again, I've talked about it a couple of times, but the negative pressure ventilation controls is a really big one, especially if it's a bathroom-driven ventilation system, just pulling the outside air in through the facade. If that's the case, that air is just not being filtered, and so it's pulling the smoke right in. And then just having common area controls that are that are being deployed appropriately. And that could be, again, that place of refuge. If you're a multi-unit residential developer or building owner, you could look at that common area as being the place of refuge that people could find the clean air. So I just have a couple of notes on existing building considerations, and then we'll wrap things up. But the big thing is going to be envelope upgrades, controls upgrades, the maintenance and having those filters in stock. I'll talk a little bit about filter modifications because there's several just things that need to be considered before you go and throw a MERV 13 filter into a fan system. Talk briefly about pressurization, what people can do, and then I'm going to end on just funding improvement opportunities. So again, talked about envelope integrity, repairing gaskets, deploying sensors, minimizing openings. These are all things that we can do in an existing building that I've already talked about in quite a bit of detail. So I'm not going to go over them again, but they're really important for existing buildings. Here's the caution I was talking about as far as upgrading filters go. So fans only have so much what we would call static pressure capability. So they can only push so much air across so much pressure that they're seeing. And when you are adding filters, filters tend to add pressure to those systems. And so I'm not going to go through each and every single one of these warnings, but ASHRAE has outlined several concerns when you are looking to modify existing systems with additional filtration, just things we want to make sure that we don't create other issues somewhere else in the building. And then we've talked about positive building pressure already. One of the simple things, and this is on YouTube, people talking about the tissue test. So you can go to your existing building, you can open up one of the doors and you can hold a tissue right next to the door opening, and you can see if the tissue blows out of the building or is sucked into the building. And that'll help you understand very quickly if my building's under positive pressure or if my building traditionally operates under negative pressure. And then from an envelope perspective, as well as a systems operations perspective, retro commissioning the systems is a great way to just ensure if I do have a smoke mode in my building, is everything working the way that I wanted it to? Same thing goes for my envelope. Is my envelope working the way that I want it to? And so whether it be envelope commissioning or retro commissioning the building, both of these are great steps you can take proactively to see how your building will be, whether your building will be ready for a wildfire smoke event. And then as far as funding goes, these are not low cost items necessarily. They can be high cost depending on what sort of modifications we need to do for the HVAC systems or for the envelopes So it's good to find alignment with other goals, whether it's looking at the natural life of, these air handling units that I have in my building, they're already 25, 30 years old. They've got these really old filters that aren't really appropriate for today's needs. They don't meet current code. They're already kind of a pain. So looking for opportunities like that where the equipment's already old, so you're addressing your deferred maintenance needs, but when you're doing that, you're also providing appropriate remedies to address these wildfire concerns. When I'm working with campuses or working with universities, they tend to have long-range development plans as well. So if I know that I need to be adding additional capacity to a part of campus or to a building, or if they're looking to change a general academic space in a lab space and they have to add that additional cooling or heating capacity, that's a great opportunity to start looking at, well, since I'm already in here making some of these modifications, what are the things that I can do to address wildfire smoke? Could be building performance goals. You could be chasing, whether it's carbon emission reductions or energy reductions. Again, trying to link in a way is, am I touching equipment that has filters on it already? If I am, is there a way that I can also make wildfire smoke upgrades as well? And then again, retro commissioning, just trying to find ways where you get a payback or you do get an ROI is the best way to approach these projects. But some of these are hard to get a direct ROI unless you're doing it with something else. So in summary, some of the key takeaways. I hope that I've shared enough information that has everyone on the call convinced that wildfire smoke presents a health hazard as well as it can have an economic impact. Air quality tools are readily available. I shared a couple for y'all to use today and moving forward, and analyze your project sites and see whether or not they're at risk of wildland fire smoke. And there's several strategies that are available. There are, many of them are HVAC strategies, but a couple of architectural strategies, of course, and you have operational strategies that are both proactive and reactive. And existing buildings come with a lot more considerations or challenges that we have to sort through, but they can be overcome. So with that, I'll open it up to any questions. And yeah, thank you all so much for having me on. And like I said, it's good to be home.
Great. Cameron, that was fantastic. I've been thinking as you're presenting this the number of existing buildings that I'm working on, and I'm sure we'll all have a lot of existing buildings, and just the deficiencies and envelope considerations, and just the number of improvements that need to happen to really have an effective system. But also the amount of emphasis you put into operational considerations and smoke plans and things like that are really good thinking. I think it'll be interesting to hear if people have questions or comments about that. Alan's got a couple of questions in the chat. Alan, I'm going to encourage you to turn your camera on, and why don't you ask Cameron those questions?
Yeah, Cameron, great, fantastic presentation, really excellent, and I can see you have some experience with communicating to architects as an engineer, so the graphics were nice too. I wanted to check in because I am not a fan of PTAC units, so I understand the challenges with those. But with the other decoupled systems you talked about, like VRF and chilled beam, those are typically coupled with some other type of ventilation equipment where you could add filtration of outside air, correct? Or are there challenges related to those systems and adding filtration specifically for outdoor air quality or smoke issues?
Yeah, really good question, Alan. So I'm going to answer this as an engineer and say that it depends. But from a most often standpoint, I do most often see a dedicated outside air system provided for VRF systems. If not a dedicated outside air system, I'll sometimes see outside air ducted inline to an inline fan and then ducted into the back of the VRF unit. When it's ducted directly to the back of a VRF fan coil unit, it's not always provided with a filter on that outside air intake. Now, if you have an outside air fan, often your mechanical engineer will put a filter on it to protect the fan. But that's where ASHRAE does make a recommendation to ensure you have MERV 13 or better on that outside air fan or the dedicated outside air system that's providing outside air to the VRF fan coil unit or chill beam. Now, the thing that ASHRAE 44 highlights with these, because that's where your outside air is coming from in your mechanical system. If you have smoke that comes through the windows or leaky gaskets or smoke gets into the space itself, you're recirculating the air in that zone with that VRF fan coil unit. And that's where the deficiency is highlighted by ASHRAE, is that because I'm recirculating the air in that space, that VRF fan coil unit, MERV 8 is really easy to achieve. You can achieve MERV 13. It's just it has some additional considerations you got to look out for because those fans have limitations from a static pressure perspective. So it's that recirculated, it's the smoke that comes in through the envelope and the fact that a VRF unit will recirculate the air in the space. So to answer your question very succinctly, DOASs are often provided with a VRF system. At that DOAS, you want MERV 13. It's the concern of the VRF fan coil unit recirculating the smoke in the space and not having a MERV 13 on that fan coil unit.
Yeah, so it would matter whether or not you had a good envelope or other limitations on potential pollutant sources, whether or not you have a problem.
Correct. Yep.
Yeah, thank you.
Yep.
Cameron, maybe this is too geeky a question, or as an architect, I don't understand it. But if I understand that if you want to pressurize the building, which is a good defense against intrusion, particulate matter. But I saw an earlier diagram where you would have return air ducts probably at the perimeter near openings. But if you already have pressurization in the building and an open window, how effective is it? How necessary is it to have return air ducts at the perimeter zones? I'm sure there's so many factors in there that.
So return air for commercial office tends to find itself around the perimeter of the building because historically that's how people have tried to address the hot air or the really cold air, the envelope effect. They're trying to pull that out of the space and push the appropriately tempered air out towards the perimeter. So it's less of an air quality strategy. It's more of a thermal comfort strategy that people are trying to do there. I can see value in the return being at the perimeter to address the envelope leakage that could occur as well. You mentioned an open window. I would not advise anyone to have open windows during a wildfire smoke event. And then from a building pressurization standpoint, it's good to ensure that you're pushing the air towards those return grills that are at the perimeter and not pulling the air deeper into the core of the building. That's why you want to have positive pressure in your building. And someone asked, how does one do that? There's a handful of ways that you can do that. One of the control strategies we use to control air handling units is a supply fan return fan offset. And you can make that more aggressive during a wildfire event if that's what you wanted to do as one of your strategies. You also have a building pressure sensor in your HVAC system for most large scale commercial buildings. And so that you could also adjust that set point. So someone asked a question, sorry for talking so long in response to your question, but someone asked smoke mode. And so in your smoke mode, you could simply turn that on or off and it could do a whole suite of modifications to those set points throughout your system. So it should just simply be a toggle on, toggle off of that mode, and it modifies your supply fan, return fan offset, your building pressure, and disables your air side economizer, just to name a couple. So Logan, I'm sorry for the long-winded response.
No, that's great. It's like with you engineers, there's a switch for that. I like that.
Yeah. So on some of my K-12 projects, because I did a lot of work with LA Unified School District, we actually had a switch that was at the administrator's office that they could turn it into. One was normal operations, one was a manual override off for the whole system, and one was a shelter in place mode, should you have any bad offenders that are near the buildings.
Interesting. Cameron, we have a question from Jennifer, and Jennifer Rogers. Jennifer, I encourage you to turn your camera off if you want to have a conversation with Cameron about this. And the question is, do you have experience with electrically charged dynamic filtering systems? If so, please elaborate. And I'm going to throw out here, because we're talking about something that's electrically charged. Jay's comment is also about power safety shutoff in moments when we don't have access to power to the building and backup power systems, and how all of these things are working together.
Yeah, I'm going to take Jay's question first because it's easier. So Jay, not always, and actually it's fairly uncommon unless you're dealing with a critical space or a critical building such as a hospital or data center. These systems I'm going to call it convenience air conditioning, because air conditioning at the end of the day is a convenience or a luxury, is not considered to be a part of the fire life safety system always. So it's not code required to be on backup power. However, when we are doing our resilience analysis with our clients, we ensure to have a conversation around wildfire smoke, and that will be a part of their profile if they want to address it and have the HVAC systems on standby power.
Right.
And then Jennifer, great question. I do have some experience on electrically charged dynamic filter systems. There's oftentimes two types. There's one that gets a hardwire connection, so it receives continuous power, and then there's one that comes pre-charged. The pre-charged argument is that it will extend the life of the filter and reduce the pressure drop associated. So the idea is that you're able to attract these particulates to kind of the edges or the corners of the dirty, unpolluted or undirty areas of the filter. And I would continue to look at them the same as I would any other filter. And I would do a life cycle cost analysis with the owner to see, is that hardwire connection going to be worth the cost compared to the life longevity that it provides? But from a performance standpoint, it will also track a similar MERV rating that I brought up earlier. So those will still need to comply with whether it be MERV 13 or MERV 14 or MERV 15. Usually the story around them is that they get longer life out of them. And I do see the ones with the hardwire connection actually performing better than the ones that are pre-charged in the box that you deploy. So it's a cost balance compared to maintenance sort of, conversation. Assuming that was your question. You asked me to elaborate, and so I just took a guess.
We're not hearing you, Jenny. Yeah,
Yep.
There you go. Hi. Jenny, it's pretty muted here, so I'm gonna ask a question. Maybe you can put if there's something more you can put in the chat. Cameron, the thing I think about, I mentioned I'm in Eugene, and I mentioned I'm often in Oak Ridge for some projects, and I think about the number of poor air quality days related to fires that are coming from smoke coming from hundreds of miles, and just the frequency of the time we're dealing with smoke. It's really not because there's a fire nearby; it's because of those days. And also, I'm thinking about just particularly with our existing schools or whatnot. There's just so many things that need to be improved to make these systems really perform properly. So, is there a difference between smoke as it's nearby and as it's traveled 100 miles and particulates may be falling out of it? Or are there different strategies that may be worth considering either from a design or an operational perspective related to distance that smoke is traveling?
I've never been asked that question, and I don't think I'm the right person to opine on it. However, I will say that the way that I guide my clients through that conversation would be to still look at the local air quality data and use that to inform decision making. So regardless of where the fire occurred, the local air quality data is still identifying your PM 2.5 to be at a certain level, or your ozone at a certain level, or your PM 10. And so that's why I wanted to spend time with the multi-year tile plot that the EPA provides, because that multi-year tile plot says that your PM 2.5 is still extremely elevated. It's a concern for your area, regardless of if it's being produced by a wildland fire smoke or if it's being produced by the highways and the traffic of the cars sitting there. So a lot of the benefits you get from particulate matter filtration is there's a lot of co-benefit of addressing highway type particulate matter, or a haboob of a dust storm that were to occur, or wildland fire smoke, any of those particulate matter offenses. So I tend to consult through the lens of what is my acute locations profile, and then that will help me drive decisions as opposed to where are the wildfires occurring in relation to my site.
Right. Oh, that's a good point. That's great. That's great. We are right at 1 o'clock. So I want to just invite anybody, if they have any more questions, please put it in the chat or turn your camera on and let's ask. And when I give people the time to do that here, I'll just remind everybody that we have a session next week. We have 2 more sessions. If someone who's looking at I'm not looking at the event calendar, but someone who is, if you could just remind me what a little bit about next week would be great. And my mind's gone blank. And then in 2 weeks from today, we have a panel discussion. We'll be speaking to our Nate will lead us in a panel discussion with our various presenters and talk about the themes that tie these these topics together.
Going to say that next week's session is focused on commercial and multifamily structure fire resistance, and so looking at what are the similarities and differences with a lot of the recommendations for residential construction that is common. If we have a moment and nobody else is asking questions, Cameron, I had one other question regarding filters. I understand the complexities and challenges and opportunities associated with upgrading to MERV 13 in certain air handling units, but I don't fully understand how easy or hard is it to do a activated carbon filter addition to air handling units in existing buildings.
In existing buildings, you need to look at what the VFD is operating at for the fan, as well as look at where the what sort of shiv modification you can do to a belt driven fan, or if it's an EC motor, how hard is it running. So you just have to see, based on that particular fan, its ability to absorb additional static pressure. So it's just getting the manufacturer and the model number, taking a look at where it's currently operating on the fan curve, and looking at, okay, if I were to add an additional ½ inch or an inch of static pressure, could I get similar, or even maybe it's okay that I'm running in a slightly reduced flow operation for that day, right? So I'm willing to sacrifice a little bit of thermal comfort so I have better air quality for maybe that week or a couple of weeks if I need to run in a wildfire smoke condition. So it's
challenges relative to the filter rack to
no, there's spatial challenges too. Yeah. So so the spatial challenges are very much a thing, but you can play around with where they get installed as well. So where are they in the duct system? Could they be cut into the duct? Is there a way to, there's usually not a way to put it in the air handling unit itself. Package equipment like package rooftop units, you tend to not be able to quickly modify them. So it's looking at doing some sort of fan filter box modification to the ductwork if you're trying to get it cut in somewhere.
All right, thanks.
So yeah, it's a spatial challenge, but from a static pressure standpoint, we would just run an analysis on it.
Okay, cool, thanks.
Yep.
That's great. Well, seeing no more questions, I think we can conclude our presentation today. And Cameron, again, thank you very much. We really appreciate your time and your wisdom here. This has been wonderful. And a reminder, there will be the presentation slides will be available, and Cameron did mention some links. So Kathy will work with the participants to get that information to you. And then this video recording will be available on the AIA Oregon YouTube channel in a few days. So thank you everybody for joining us, and thank you, Cameron. Enjoy the wedding, and we really appreciate your making it, being able to fit us into your schedule, and everybody have a great weekend. Go Ducks.